Okay, good scene. So now today we are going to learn about another subtopic. It's called the path difference. Path difference. Alright, kids. So path difference is basically the difference in length between a point within the interference pattern from both the slips, like that. I'm going to explain this in a bit, so you guys just hold on. Generally, path difference is given by n lambda. Alright. Where lambda is, wavelength. Lambda is wavelength, and n is the number of order, like 0, 1, 2, 3, and so on. Okay. Just like we learned about the first one was bright, and the second one, like, zeroth order is the first maximum, then the first order is the second maximum, and so on, like that. Okay, kids. Which means that if there is constructive interference, which basically means both sources are in phase, then n has to be equal to 0, 1, 2, all whole numbers, like that. Okay. Now, if there is destructive interference, which means, and this is for like the both sources in phase. This means that at this point, both sources are anti-phase. They are going to completely destruct each other. So that would mean that then you got to take n as half, 1.5, 2.5, and so on, like that. Is it clear, everyone? Any questions, please let me know.
Yes, sir.
Good. So you please write this down. And then we're going to go forward. If you have any questions, please let me know. All right. Hamayal Rahil, how are you?
Yes, sir. I'm fine. How are you?
Okay. Have you done anything AS before?
No, we haven't done that yet.
You haven't done this yet. Okay. You can learn this chapter. Basically, we're gonna do electricity after this, and then nuclear physics after. That has nothing to do with any of this or anything you've done before. And then you can join Furkan takes catch-up classes for this, so you can join him for the catch-up classes every Saturday and continue with this group. Okay, Mael?
Okay, sir. Thank you.
All right, kids. So then,
Sir, are you talking about the catch-up class on Saturday?
yeah, Saturday. This Saturday, I still won't be able to take it because I'm traveling since 2 weeks. So that's why I couldn't take classes for A2 and AS like last 2 weeks. That's the issue. Last week and this week, I won't be able to. Like next to next week, I'm gonna restart them.
Okay, sir.
Let me check a good interference pattern that we can see to analyze it then. What this is. Let's take this. Okay. Now, when the double slit interference pattern is created like this, जी? नहीं, नहीं. So I just want to tell you how it works, so you guys should know. In the very first, like I said, when there are two solid lines meeting, which is right here and here, 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 here. So in the very center, you get a maxima. That maxima is the zeroth order maxima. Now I will be explaining why it is called zeroth. The next maxima is here, 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 here. So you can basically go in a straight line. This will be the maxima that we call the first order. And then here, 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 we also call this as the first order. Okay. Then this one, this one, this one, this one, you can take it here. This would be called another maxima of second order. And this one will be called maxima of second order as well. Now the point is, why are we calling these second order, first order, whatever? Okay, wait. Let me just put the markers so that we know exactly where we're looking at. Just remove this. Okay. So if you go in a straight line from one slit, for example, this one, to the first zeroth order one, like that, and like this, you realize that both these lengths are equal because this is an isosceles triangle that is made. Is it clear, everyone?
Yes, sir.
So if I wanted to find the path difference, so the path difference here would be this side, let's say S1 and S2. So S2 minus S1 is 0. This is the reason we call this as zeroth order, or n equals to 1, because if n is 0, then n lambda will be 0 as well. Do you get it? Now let's look at the next one. If you go from S1 to this maxima, oh, like that. And from here to this, you might realize that this length S1 is smaller than S2. Do you guys agree?
Yes.
And how small it is, it's basically if you draw a straight line with them, so it's just a lambda small. This is why we call this as first order, because here the path difference is just equal to a lambda, and which means n will be equal to 1. Understood? Because n, you can get only lambda when n lambda, you put n as 1, so it will be just lambda. Get it?
Yes.
I'm also going to check the last one.
Sir,
Yes.
could you repeat the lambda thing?
If you check, the S2 line, blue one, is greater than S1. You agree?
Yes, sir.
So from this point, what I want to tell you is that the difference between the lengths of this length and this length is basically this much. You get it?
Yes, sir.
This is just a lambda. So when you subtract these two lengths, it will come out to be just the lambda, which means n has to be 1 in order to get 1 lambda. Get it?
Yes, sir.
If you go to the next one, starting from here, go here, and go here, you might realize that actually now this S2 is now even larger than S1 in length. You agree?
Yes.
So now how large? Now it will be equal to 2 lambda. So path difference here would be 2 lambda. And why is 2 lambda? Because n is equal to 2. And n lambda can only be 2 lambda when n is equal to 2, which means that the next one will be 3 lambda, and then 4 lambda, and 5 lambda. Get it? Like that.
Yes.
Good. Same goes for this one. If I ask you what will be the path difference here, you can simply say 1 lambda. What will be the path difference here? You will say 2 lambda, and get so on. If there were minimas, then we would say in the middle, because minimas are in the middle, like in this one. Minima would be equal to half lambda. The next minima is going to be equal to 1.5 lambda. The next minima would have been 2.5 lambda, like that. Get it?
Yes.
And identically, we will also see the same pattern on the other side as well. Now, the solving questions from this is very, very easy. You can basically, you have the notes shared, so you don't have to draw this. You can actually look at it later on. But if you want to draw it, that's fine. But technically, the questions are super, super easy. For example, you guys have done? Should I go forward, please?
Yes.
Yes, sir.
Furqan, Fatima, and Asma.
Yes.
Shazib, you're also done? Imail is like new, so she might have some difficulty understanding this. Chalo, never mind. Let's go forward. So, for example, they have shown a path like that, like this, and like that. Uh-oh. Sad. It's not letting me, Oh my god. Okay. Chalo, isko mita lete hain. It's just causing trouble. Nothing else. Okay. So, now I just want to tell you, they said this is A, This is B, this is C. This is 4 centimeter, this is 6 centimeter, this is 12 centimeter. They say a source of microwave sends the wave in two paths, A, B, and C. A, B, C, and A to C directly. So if it's going like that, then this or this, and this, sorry. It says if the wavelength is 2 centimeter, deduce whether at C a constructive or a destructive interference takes place. So we want to do that. Let's check it out. It's pretty easy. So I'm gonna tell you, I'm gonna show you. So path 1, or we could say path A, B, and C would be 4 plus 6, which is 10 centimeter. You guys agree?
Yes.
Let's call this path 1. Path 2 is going to be A directly to C, which is 12 centimeter. Now I want to find the path difference first, which is going to be 12 minus 10, so 2 centimeter. Agree? Do you guys agree?
Yes.
Now path difference is equal to n lambda. So I'm going to write 2 centimeter equals to n times, what is lambda? Lambda is also 2 centimeter. So n will come out to be just 1. What does that mean? The whole numbers represent?
Constructive.
Yes, so we'll say at C, constructive interference is seen. Did you guys get it? So simple like that.
Yes.
Very, very nice. So you can copy this, please. If you have any questions, ask me, and then I'm going to give you people a question. And then we'll move to diffraction grating. I think waves as a chapter is the easiest, and because it is just, there will be a short question from it every single time in the exam. So you don't want to lose marks on this simple things, on these simple things, I think. All right. Now going to the next, okay? Done writing? Should I move forward, please?
Yes, sir.
Yes.
Okay, now it's time for you people to prove that you understand this. So, example. So there are two dippers, dipper D1 and dipper D2. So there's a point A, and then there's also a point B. So it goes like that, this, and also this and that. This is 5 centimeter. This is 7 centimeter. The other two distances are 5 and 6 centimeter. Now in the first one, so they've said D1 to A, D2 to A, D1 to B, and D2 to B. They've given distances. Do not get confused. This is 5, this is 7, this is 5, this is 6. Now, they say wavelengths of water wave is 2 centimeter. Number 1, state whether the state the appearance. State the appearance with respect to displacement at A and B. Let me just move this to the other page because it's not fitting in. Wait. Just like that, kids. Okay. Can you guys do this and let me know what would you see at A and what would you see at B, please?
So I got an answer.
Yes, please.
At A, it is n equals to 1, so the displacement is maximum, and at B, n equals to half, so it's 0.
It's 0. At B it will be 0, and you're saying at A it will be maximum.
Yes, sir.
Anyone else who got the same answer? Yes, Asma, Dania, Fatima, Furqan. Ismail, you can try it now. And Raza, Shazib, hurry up, please. at A1, at B half. Okay. So what conclusion do you have? You also need to give the conclusion, please. So like, right. It's good. Okay, so now kids, you've done the right thing, which is good. So you need to do at A, you just need to basically find the path difference. And the path difference at A will be D2A minus D1A. Yes, Raza, that is correct. Okay. Which means that this is going to be 7 centimeters minus 5 centimeters. That's going to be 2 centimeters. And then when you find the path difference, it will be 2 centimeter equals to n lambda. Lambda is basically equal to 2 as well. So you will get n as 1. Now in this point, you guys need to write 2 points actually. Number 1, you're going to say there will be a constructive interference. That is true. But then the other thing you guys need to write is that then a large displacement is seen, because he's talking about water waves. I'll tell you why it is important in a bit. For part B, so you could have written at B.
So instead of large, can we say maximum?
No, you cannot. Maximum happens at the center. You can't say that. Is it clear?
Okay.
This is not the center. Center is at 0. Part difference now in that one, which is D2B minus D1B, has to be 6.0 centimeter minus 5.0 centimeter. That's 1.0 centimeter. Now, when you put it 1.0 centimeter equals to n lambda, so n times 2, which basically means n now will be half, which is 0.5. The moment you get half, you should understand that you're going to write 2 points. There will be a destructive interference, and now no displacement is seen. Alright, kids? Because they're going to cancel out each other. Now, the fact of matter is, fact of the matter is that now there will be 3 types of waves that they're going to give you. All right. So you will be having water. In case they give you water, you are going to discuss their maxima and minima. So how do you address these? So for water, you say displacement or no displacement. Is it clear? Good here. Or no displacement. If they give you light, for instance, so for light, you can call this maxima as bright spot and dark spot. And for instance, they give you sound. Then you are gonna talk about loud, sound in constructive, and quiet in destructive. Is that clear, everyone? So you need to write this right terminology, whatever the question is about. Do not mix it up. If you had written bright spot in this, the examiner would not entertain that because you haven't really read the question carefully. Get it? Okay. Now, from the same question, there are two very important parts that I wanted to do it myself, and then we will be finished with path difference actually. So I'm going to go to the next part of this question.
Sir, can you please scroll back up first?
Yes. Okay, here you were writing this one.
Yes, all of this. Thank you.
Okay, good. Oh my God, sorry. That's not fair.
Thank you, sir. I'm done.
Okay, good. So the next part of the same question states that the dippers are then changed such that they vibrate at 180 degrees. Phase difference. State the change at A and B, if any. Alright, so they want to answer that. Now, when they were vibrating together, A got constructive interference, B got destructive interference. But 180 means now they will be vibrating in the opposite directions. If that happens, so write a small note here. If sources become 180 degrees phase difference to each other, then where constructive interference was happening, now destructive interference will happen, and vice versa. Like where destructive was happening, now constructive will happen. Do you guys understand that? So with respect to this question, we can say at A, there will be no displacement now. There was there was large displacement before. And at B, there will be a large displacement. So you got to flip the answers because they have also flipped the direction of or the phase of both dippers. Understood?
Yes, sir.
Write it down, please. Then we're going to answer the third part of this. All right, kids. Now, let's go to the next. So the next part of this one basically tells us about, let's write it down first. It says now intensity, we've already done it in the previous question that we learned before. Now it says that intensity is increased for dipper 1 and kept same for dipper 2. State the change at A and B, if any. All right. So obviously, if at A there was constructive interference, first the wave would look like this, and now the new dipper has a bigger wave. So when they meet constructively, they're gonna make even a larger wave. Do you guys agree?
Yes.
So we can say at A, and even larger displacement is seen because you have increased the intensity of one. But then, if one dipper had the same intensity, but the other had increased intensity, but now it was like in anti-phase to each other. So when they do, it's not going to cancel each other completely. They're not going to do that. So some wave will be left. So it
why is
means,
it anti-phase?
sorry,
Why is it anti-phase?
why they're anti-phase? B was anti-phase, that's why. B has destructive interference, right? That's why.
Okay.
Yeah. This part has no relation with 2. It is like asking about this one. You get it? Okay. So at B, there will be some displacement. Now it will not cancel out the whole wave completely, as waves do not cancel each other completely. Is it clear?
Yes.
You guys can write it down, please. This is how basically it works, okay? So they can give you the same type of questions every time. You guys just need to figure out exactly what they want to answer. They ask. You just need to go through the path difference first. See how different they are. Divided by lambda, check if it's a whole number, they will be constructive. If it's not a whole number, then it's going to be, if it's a 0.5 thing, then it's going to be destructive, and so on and so forth. It's not that big of a deal. If they change the phase, you switch the results. If they change the intensity, then obviously it will not cancel everything completely, and then there will be a different displacement when there's constructive. All right, kids. So this is basically all for this one. We're gonna finish this whole wave section. Probably, yeah. In the next class, we will be able to do that, and then we'll move to electricity, which is the second last one. Hopefully, we'll finish the whole syllabus by December. All right. See you then. Have a nice day. Bye.
Thank you, sir. Love this.
Thank you so much.